We're going to walk through the process of setting up Visual Studio Code to develop projects for the XMOS xCORE series of microcontrollers. Before we begin, we'll need the XMOS Toolchain installed, which is called XMOS Xtime Composer or XTC tools. If you don't already have one or more of these toolchains installed, you'll need to go to the XMOS website, download and install it. You may need to create an account and sign in before downloading the tools. We're going to be using XTC Tools 15.2.1. If you're targeting older microcontrollers, such as the XS1 series or the XMOS Start Kit, you'll need to use version 14. We'll just wait for the download to finish. We'll open the installer disk image and drag the tools to the applications folder. This, with an object with an XMOS icon, is actually a folder containing the tools. We can eject the installer disk image and go to our applications folder where we see the XMOS XTC 15 tools. One thing that is very useful is this setenv.command. This is a script that opens a terminal window with the XMOS toolchain environment variables already set. We'll be using this later. Before you're able to run this script, because it's not signed, you will have to right-click on it or control-click and choose Open. And now you have the option of opening it even though it's not signed. Let's make the text a little bigger in this terminal window. Now I have an xCORE 200 Explorer attached to my computer. If I go to System Preferences, if I go to About this Mac and look at the system report, under USB, I can see that the XTAG3 JTAG programmer is attached. Let's see if the XMOS tools can see the attached board. L is for listing the attached devices. Now I'm using an Apple Silicon-based Mac, and the executable is probably an Intel executable. If you've never run any Intel applications on your Apple Silicon-based Mac, you'll need to install the Rosetta tools. Let's try that again. And there it is. My XTAG3 programmer is detected. Usually the Rosetta tools, which is sort of a dynamic recompiler to run Intel applications on an Apple Silicon Mac, usually those tools are installed automatically the first time you try to run an Intel application. But they don't seem to install automatically if you're running a command line application from the terminal. That's why we manually installed Rosetta. So now we have a functional XMOS toolchain that we can run and see our board from. The next thing we need to do is download and install Visual Studio Code. code.visualstudio.com. Of course, we'll download it for macOS, and we can use the Apple Silicon version or the Universal. Or if you're using an Intel Mac, you can use the Intel zip. The Universal contains both binaries, but if you choose either Apple Silicon or Intel, you'll have a smaller application taking up less space on your disk. There's the application. Safari already unzipped it. You may have changed your preferences in Safari, or your browser may not have unzipped it. In that case, just unzip the file and take the .app application and put it in your applications folder. Let's go to the applications folder and check out Visual Studio Code. I really like Visual Studio Code. It's fast and has a lot of useful extensions. I'm going to go ahead and drag the Visual Studio Code icon into a permanent place on my dock. I'm also going to go into the XTime Composer tools. I'm going to put this command in my dock as well. I can put it over here. It's a file. And that will open up a terminal window with the XMOS environment variables set. Let's try that out. There we go. When you try to terminate this window or quit terminal, it complains that something's already running, and that's because you're inside a secondary shell. If you choose exit, then you can quit terminal. Now we want to download the XC-IDE extension for Visual Studio Code. Right now, this extension is not published on the marketplace, so you won't see it listed here in the extensions section. It's published as a vsix file that you can directly install. So the full URL is bitbucket.org/kpatterson/xc-IDE/downloads. The vsix is a compiled Visual Studio extension that you can manually install in your copy of Visual Studio Code. Just click on the file to download it. In Visual Studio Code, go to the Extensions sidebar, click the three little dots in the upper right corner, and choose Install from vsix. Go to your Downloads folder and choose the extension that we downloaded. I'll try to take care of this publisher information in the future. Right now, the README provides some useful information, as well as some links at the bottom. Please take the time to read through the README and familiarize yourself with the contents and the concepts. We won't do that in this video. We'll assume that you've already taken the time. So this would be a good place to pause and read it for yourself. There's a couple other extensions that we would want to install. Besides the XC-IDE extension, it's nice to have syntax highlighting for .c and .cpp files because both types of source code are supported on the XMOS platform. This is the one that we want right here, C/C++ by Microsoft. This is going to prompt you to install the command line developer tools for Xcode if you don't already have them. I skipped ahead until the software was finished installing. One thing we need to do is make sure that the path in our terminal is updated to include Visual Studio Code so that we can launch code from the terminal. Press Command-Shift-P and type shell command. You'll see an option to install code command in path. Let's go ahead and do that. Let's go ahead and quit Visual Studio Code and make sure that this works. I'm going to launch the terminal using the set env command so that we have our XMOS path and environment variables. Let's see if we can launch Visual Studio Code by typing code and pressing enter. There we go. This is important because to use the extension properly, we need to have Visual Studio Code running with the environment variables and path to the XMOS tools available. So we launch it from that environment. To demonstrate the use of the XC-IDE extension, we're going to make a copy of a sample Xcode workspace. This can be found on my project page on Bitbucket, bitbucket.org/kpatterson/xcsample. You could clone the repository, but you probably don't want to do that because you're not going to be committing back to it. Let's go to Downloads and download a zip of the repository. It's probably going to put it in your Downloads folder. Let's go there. You're going to want to rename this to something like XC Hello World. And let's put it somewhere useful. I'm going to put it in my Documents folder. I'm going to make a folder here called Devel for development work. Put that inside. So basically, I have this in Documents, Devel, and then XC Hello World. For now, let's see if we can open up this workspace in Visual Studio Code. We've already launched Visual Studio Code from the XMOS Tools environment. So let's go to File, Open Workspace from File. We'll just browse to it and open the workspace file. Now that we have the workspace open, let's explore a few features of the XC-IDE extension. To make sure that the XC-IDE extension is automatically activated, there's a small file called .xc-ide. It doesn't have any content. As long as that file is present in the root of the workspace folder, the XC-IDE extension will be automatically activated. When the extension is activated, there are several buttons down here on the status bar, and I'll explain what they're for. This is the language type or language mode. This selects which device that you are targeting when you run or flash an executable. And then this is a quick button to run the executable, and this is to flash the executable. Let's take a look at the source code for main.c. Now, this source code is in a parent folder called src, which is under main. So main is actually the project title. You can call that whatever you want. It just needs to have its own Makefile, and then the source is all the source code is under a directory called src. And there can be subdirectories and so forth recursively. This is a really simple example that simply prints hello world using printf, which goes through the debugger. And Visual Studio Code is prompting me, do I want to install the extension pack? We probably don't want to do that. I don't think it will hurt anything, but it's not necessary. And if you look at one of the Makefiles, it's going to prompt you to install Makefile tools. There again, it's not necessary. I don't think this one will hurt. I'll go ahead and install it. That way it quits bugging me. I think it just provides some IntelliSense for Makefiles. Let's go back to our source code. So we only have one function. It prints hello world and then exits. The type of this file is .c, which is C code. It could be .cpp or .xc for XMOS extended C. There is a syntax highlighting language support in the XC-IDE extension. So if we rename this to, let's say, XC, which is largely compatible with C, you'll see that the file type here is now XMOS XC. Not sure why it's not highlighting pretty colors, but anyway, we'll change it back to C. Now, if you want to build this project, you simply press Command-Shift-B, which executes a build task. And you can see the output down here of make. And it produces an executable in the bind folder, main.exe. If you have multiple executables, you can have multiple targets. There might be different projects that you work on that they work together, but they're independent projects with separate executables. You need to set at least one executable active, and you just right-click on it and choose Set Active. And it tells you that the target platform is xCORE 200 Explorer. This file indicates which target platform is associated with which executable. So it has the same name as the executable and then underscore target.txt, and it only contains the text of the name of the target. If you want to know what the target names are, we can look in the Applications folder under the XMOS toolset. In the Targets folder, you can see all of the different targets supported by the XMOS toolchain. And we are using this one, xCORE 200 Explorer. There's targets for individual microcontroller chips, as well as the different development boards that XMOS has released. Again, if you want to use a XS1 series chip or the Start Kit, you need to use the Xtime Composer Tools version 14, not 15. So just make sure that the target name is in here and that it has the same name as the executable with this .target.txt at the end. And then all the make files will work, they'll recognize that, and everything will be great. If we want to run this, we just click the Run button. But first, let's see where it's going to run. The JTAG button shows you the different devices attached to your computer. There's the simulator, xsim, as well as an XTAG3 adapter that I have connected, which is plugged into an xCORE 200 Explorer board. Let's target the Explorer board and click Run. You can see that the executable was run using xrun on the Explorer board, and the output of printf appears here in the terminal. You can also flash the executable to a device using the Flash button. Let's take another look at the JTAG menu. We have the XTAG3 debug adapter that I have attached via USB. Then we also have the simulator, xsim. Let's try running on that. Let's clear this window and click Run. You'll notice that we're running on xsim, and there again we have the output of the application. If you try to flash on xsim, you simply get a warning message that you cannot flash to the xsim simulator and to choose a JTAG device instead. I'm going to plug in another target board, which is an xCORE.ai board. If I go back to the JTAG menu and click refresh, it should show up. There it is, xTAG 4. That's my xCORE.ai board. Now if I try to run it on that board, it says that it does not match the architecture. What I need to do is change my target. Let's take a look and see what the correct target name is. xCORE AI Explorer. Let's save that. Let's rebuild, Command-Shift-B, and then run it. Successful. So that's pretty much all there is to the XC-IDE extension. It facilitates building, running, flashing, and choosing your target via a JTAG menu, as well as providing XC syntax highlighting. I want to tell you a little bit more about the structure of individual projects. First of all, there's a top-level Makefile, and it has different targets. All should build all of your projects. Right now we only have a single line here for the main project. And then we have a target called main, which just builds the main project. Remember, this can be called anything you want. If you don't want it to be called main, we could call it hello world, something like this. We'll also want to put that, if we're going to rename the project folder, in these other places. And then clean is to clean your projects, similar to build all, but deleting the build files. Since we renamed our project, let's call this hello world. And each project folder has its own Makefile. There's probably not much that you want to change in here, but you could change the name of the executable if you wanted. Let's delete the old executable and rebuild the project. You'll notice that it's complaining that there's no such file as helloworld.exe_target.txt. What we need to do is rename this target file to match the name of the project executable. Let's try rebuilding. Looks like the build was successful. We need to set our new executable as active, since the name changed. And there it is. The only other thing you probably want to take a look at is under the config folder, there are two MAK files, which are sort of like include files for Make. Core.mak contains the magic that makes the Makefile system work. You really don't want to change anything in there, although you could explore it if you want to learn how it works. Config.mak is where you would specify any libraries or other include files for your project. Finally, if you want to save your project, create a repository, and do source control, you probably want to update the README file so that it reflects your own project and not the sample Visual Studio Code workspace. Now that we've finished with our overview of the XC-IDE extension, let's close Visual Studio Code and exit out of our terminal to demonstrate how easy it is to get back to the project you were working on. Just launch a terminal through setenv.command and then type code to launch Visual Studio Code. It should open the workspace that you had open before with everything just as you left it. We can press Command-Shift-B to build. We can select our JTAG device, and we can run our application. We do have to set the active executable. And there it is. There is a keybindings.json file. This is a file that can be copied to your Visual Studio Code key bindings. The file from a workspace doesn't have any effect, but it gives you a starting point to add some keyboard shortcuts to frequently used commands and try to make sure that they don't interfere with other keyboard shortcuts built into Visual Studio Code or other extensions that you may have activated. That's all for now, and thank you for watching this overview.